And thank you to the organizers for putting together such an amazing event. I think without events like this, the entire R ecosystem wouldn't be quite as developed as it is today. So organizers, thank you so much. Big round of applause. Thank you. Thank you very much. All right. My name is Ekster, and I spent the last decade or so working in this niche field called alternative data research in finance. I'm very excited to talk to you about it, but first let's define what alternative data in finance is all about. So the basic premise of alternative data is it's a process used to generate investment insights that don't come from the regulatory market operations or trading operations themselves. So it's alternative to today's traditional inputs into the typical investment research process, things like company filings, industry analysis, or information from the exchange systems like prices or volumes. So basically, the one way to think about it is all the data that comes with a standard Bloomberg subscription is traditional, everything else is alternative. And many people would be surprised to find out that most of the financial investment industry does not really run on alternative data. The stuff you hear about hedge funds trading, Twitter feeds, or news sentiment analysis is actually still just kind of a small sliver of the strategies used for most assets under management. Mostly it's traditional. So I've been part of the alternative, so I've been working in Majestic Research, which was one of the pioneers in alternative research, then SAC Capital running an R&D group there. So here I can share with you some of the examples and techniques of how this stuff gets done. Okay, so a quick example. Let's pick on the lodging industry. So glossing over a whole lot of details. Investors care about a couple of key metrics, and one of them is obviously revenues, right? Revenues are usually given once a quarter, and if we have an estimate of revenues before they're announced, if we have some kind of model or some kind of data, then we stand to potentially make a profit in the markets. So the components of revenues in the lodging industry are occupancy and room rates, and you multiply those together and you get revenues. So let's, some colorful examples of alternative data in this context. For occupancy rates, how can we know occupancy rates or get a understanding of occupancy rates of hotels before they announce it? Here's an idea. I mean, it's an illustrative idea. Look at the number of lights that are on at night in front of these hotels. Okay, I mean, this is a this is a bit of a illustrative example again, but it just goes to show you that there's interesting data like this out there. I've seen similar things done in the utility industry using these electromagnetic detectors to figure out the output of a utility plant. If we want to get the room rates, that's a little bit more straightforward. These things are on the hotel's website, on Kayak, et cetera, so we can record this data, let's say daily or weekly, and then once we get these data points, we can do some, obviously it's a biased sample, so we need to do a little bit of math on top of it to get it to predict our revenues. And so this is what alternative data is all about. It's about using information that's not necessarily obvious or well-structured to create some returns based on this information. And this kind of approach is not what a typical buy-sider or sell-sider would think of even 5 years ago, but I think today they might, because this industry has really grown quite quickly. A lot of people are aware of these methods and techniques, but they're still seldom used. Okay, let me talk about some other examples of alternative data in finance. So these are things like this is data from the broader world around us. And what's interesting being in this field is it really makes me look at the world in a whole new way. Like maybe there's that order number is sequential, so I can understand the sales volumes for that company. Maybe there's a pattern in that serial number, so I can understand how the factory produces things, and I can get some insights into the supply chain there. Some other examples of alternative data, point of sale transactions, online behavior, purchases, online, offline, obscure public records, drone footage. Actually, I've never worked with drone footage, but I have worked with satellite imagery, counting cars in parking lots, and other things like that. So it's a whole ecosystem. There's a whole ecosystem out there that's budding for this kind of data. And obviously, finding this kind of data can be challenging. But it's become easier due to the shift of the alternative data ecosystem. So within the last 6 years, the rudimentary data economy has been transformed to a fairly sophisticated marketplace, populated with discerning vendors, intermediaries such as data brokers, and now a growing list of online data marketplaces. Also, a lot of data out there is public, but just difficult to aggregate. For example, things like municipal real estate or permit records that may be still in non-electronic form. And there are vendors out there that can aggregate this kind of data and give you a very noisy but still holistic view into the permit activity across the United States. Using data like that, an investor or alternative data researcher can then get insights into things like the home building industry, or the construction material industry, right? Things like that. So there is also a growing plethora of available free or free-ish data online. And I've seen a reluctance in my industry to use these data assets to create models or to augment models, maybe because of a perceived lack of value, because these things are basically free and they're quite structured. Free unstructured data isn't free. But still, I think there's a great opportunity to, these are all very recent phenomena, relatively speaking, and so there's a great opportunity to either use this kind of data to create interesting models or to augment existing models and enrich. And actually, we're going to walk through how to use R to help augment a model in a second. Keep your phones out. There's even more free-ish data sets. And actually, a lot of these guys have RESTful packages out, RESTful APIs out. And some of them even have R packages, which make accessing this kind of stuff as simple as writing 2 or 3 lines of code. The ones I know about that have an R package are QuantMod, TrueFX, Quandl, iBrokers, Penn, WorldTrade, Yahoo, ThinkNum. I'm sure there are many others, and many of you know ones that I don't know of. But anyway, getting this data is easier than ever. So let's talk a little bit about how an alternative data researcher generates returns. There are many different ways, but the predominant way is revenue estimation. We typically don't use alternative data to predict security price movements directly, and the answer to why is fairly complicated. I'll be happy to talk after the event about it. But so typically we use the data to predict part of the supply chain. So like a lot of data speaks to revenues, so we use it to predict revenues. Other gap measures, so margins, EPS, if you can, or non-GAAP measures that are important to investors, things like churn for subscription companies like Netflix, net ads, gross ads, etc. If you have the right data set, you can monetize it in all these different ways. Okay, so from now, for the rest, I'm going to focus about predicting this revenue prediction problem with alternative data. And we come to this common challenge in the alternative data industry, which I call the small sample problem of big data. So we have very interesting multidimensional data about our hotel vacancy rates in different cities, or our parking lot counts, and it's terabytes of data, very, very interesting stuff on one side. And on the other side of the model, we have quarterly data points, and if we have only a couple of years of back data, then we have 8 or 12 data points to regress against. So that's not much of there's not much you can do there, right? There's not much of a model you can build. So, so what to do? And the answers have to do with obviously reducing, dealing with model complexity and dealing with data mining overfitting issues. And I'm sure many of you here know much better how to do this stuff than I do. But I'll talk about the last interesting point here, which is to try to reduce, to try to increase the sample size. Now, one way to do it is to reduce the number of models. Many people in my, many attempts in my industry, I see people model people create company-specific models. And so, they build 500 different models, and 20 of them have a correlation of above 0.95. And hallelujah, right? So one way to do it is to just use maybe one model for multiple companies, maybe an industry. The other way, the other method is to try to get more data points by trying to get, instead of quarterly, going to monthly data. But monthly data is typically not available. So one thing we can do is try to estimate monthly data. And I know the problem there of a model on top of a model, but it will, I can show that it will help us a little bit to increase the sample size by threefold, going from quarterly data to monthly data. Okay, so this brings us to interpolation. So interpolation is the jealous, underappreciated twin of forecasting. And we can interpolate in several different ways. Linear interpolation, spline interpolation, many economists use that. But I'm going to talk a little bit about all of them, but also a way to use external data sets, some of the data sets we've talked about earlier, as predictors to help us estimate our monthly revenue from the quarterly data. Now, the assumption here is, of course, that correlation on the quarterly level, or a time, not correlation, but a better time series metric on a quarterly level corresponds to the same on a monthly level. And we're implicitly stating basically here that two economic time series, of course, if they go along on a quarterly level, there's an underlying trend that affects both of them on any time frequency, or either they affect each other. So which tools do we use? Which tools can we use to do this? Well, R, of course. And why R? For many reasons I list here. I mean, Rob J. Hyman's package is for me enough. But just broadly speaking, in fundamental investment research, unlike the quant field, many times analysis is a non-repeatable exercise. So we're tasked with the challenge of creating a model to address an investment thesis within a matter of days. It's a time-sensitive thing. We need to create new answers from our alternative data, that models that don't exist yet. And I can't think of, this is for me where R really shines, with leaning on the community in many different respects, CRAN, and it takes days or hours to build stuff that in other languages can take weeks or months. Okay, so I'm going to walk through an actual example of how we can interpolate monthly revenues from quarterly, and I'm going to pick on this company called Fastenal. It's a fascinating company that sells fasteners, and the ticker name is FAST. They sell like industrial supplies, mostly wholesale, nuts and bolts and safety equipment. And for the most part, they're a pretty typical company, except for one thing, and I'll go into that in a second. And so what we're first going to do is we're first going to interpolate these revenues in a linear way. And so with the linear interpolation here, we can get our monthly data. And so this brings us to why I picked FAST, is because they're one of the few companies in the US that also report their revenues monthly. So we can check our estimates against real data. And here we can, I use a mean average percentage error. So we have our linear interpolation. I do it on a cumulative basis. And so we can see the staircase-like structure of our interpolation, where it jumps from, it splits the quarterly revenues equally into each month and jumps from month to month, okay, with the zoo library and approx. Okay, we can do a little bit better with spline interpolation. It gives us, more of a gradual, the assumption is more of a gradual change between quarters rather than a step change. Okay, a little bit better. But what we can do here is we can use now external data. We can try to use external data to do the same thing, but a little bit better. So the approach is grab a bunch of external time series. We're going to grab it from Quandl, one of the sites I've listed earlier. We're going to aggregate them to a quarterly frequency, but we're going to make sure that when the ones we grab are monthly, and we are going to create a distance metric between the Fastnell quarterly time series and the ones we grab, and then we're going to use a spline type of regression, but with external data points to try to fit that. Okay, so finally, some code, all right? This is fairly trivial code. All it's showing is how easy it is to grab some data from Quandl in R. We're using the R Quandl package. We're giving them a bit of a break by adding a sleep between every page grabbing cycle. And so we're grabbing a bunch of time series, and we're going to take a look at them and see if any of them fit the bill to help us. Okay, and so we've grabbed a bunch of time series. We've done a distance metric on them. Now, spurious correlation, you say, maybe. We have a time series metric that's a little bit more sophisticated than correlation, a little bit more conservative. But we also have to use common sense, obviously. So we found several metrics across different data sets. And it's just interesting that today, with just a few lines of code, you can compare your time series against time series with BLS, US Census, Federal Reserve. Before, even like a few years ago, you'd have to pull your hair out trying to get it all into the same type of feed, or you splurge from a Bloomberg terminal, and even then their API So here we can grab all this data. We can see, we got one that looks pretty good. Merchant wholesalers, durable goods, metals, monthly basis, Federal Reserve number. Does it make sense? I mean, you've got the industrial space here, so it could make sense for our company, Fastnell. Manufacturing hiring rates, sure, it could. So, again, the implication here is this monthly time series will guide our quarterly spline. And here's an example of one of these data sets. Okay, and so here's a normalization function that basically takes one of these monthly time series and puts it on a scale that we can then use to better interpolate between every month. So it sort of does it so the time series add up, all the monthly data adds up to the quarterly data of Fastnell, but on the monthly basis, they each do their own thing, but on the quarterly basis, they add up to Fastnell. Okay, so now we need a system to help us. What kind of system can we use to use this data to integrate this data and interpolate between the quarterly to get the monthly? So we need, our desired solution has a couple of things. One, a monotonically increasing solution because revenues are typically not negative. We want to capture local density of these external time series. We want to guarantee that the solution passes through certain points like interpolation does, not like localized regression, because we want it to add up to the quarterly numbers. And we want to penalize changes in curvature. Sometimes these cubic splines do some weird things. And we want to also allow predictor weights so that we can use the correlations from earlier to actually weigh the localized regression like Lowe's does. And we can probably come up with some semi-parametric problem model ourselves, feed it to a general optimizer, or we can lean on the R community and find a guy in Germany who spent the last 20 years doing exactly this, okay? And here it is. It's this package called COBS, and here it is in action. And we're basically doing exactly what we set out to do. We mandate a monotonically increasing solution. We feed in the weights we want for each of the intra-quarter points. So our initial correlations will weigh the solution. We feed in the point-wise constraint that it must pass the quarterly sums, and we have a solution. It actually also gives us the confidence intervals, which I don't have here, but here we can see that our Cobb's mean average percentage error is pretty much twice as good as our spline estimate. It's better than lowest, and the lowest line doesn't pass, so the asterisks are the quarterly points. This is all on a cumulative basis. So the asterisks are the quarterly points we want to interpolate through. Our Cobb's line interpolates straight through it. It does a good job of trying to fit the intra-quarter points from the external time series and gives us a pretty good solution. So, in conclusion, let me take a moment to offer a word to the funds out there. I suspect that in 3 to 6 years, the same kind of presentation is going to drop the word alternative from the title. You can think of it as an arms race or simply as a competitive advantage. But either way, once adopted by a portion of the market, the rest of the market has to adopt to stay competitive. So no matter whether a fund plans to make, buy, or just download the data, it's good to think about an alternative data strategy. And if lack of big data of back data is giving you pause when building models, you can always interpolate using the monthly techniques you saw here. Thank you. Let's get some drinks.